Hey everybody, Dave Johnson here again with AggressiveFun, and today we are going to do something new. It's a new feature that I'm going to call What in the World Is That? And what I'm going to do here is go through different items that here today, this is the very first one, and I'm going to go through it today with something that I actually know what it is, because I have one that is kind of misleading, and then I have one that isn't, and I'll show you that in a second. But the whole point of this is to go through all of the items that I have that I've collected over a long period of time that are cool and interesting, but sometimes it's deceiving. Maybe you don't quite know what it is or what's in there. Now, this also is going to be a challenge segment. What I'm going to do is, on one like this where I know what it is, part way through the video, I'll say, okay, before I reveal this, leave your guess at what it is, or if you know what it is. In the comments, leave your description of what the item is. And then I'll go on to tell what I know about it. In other cases, in future, what in the world is that? I have items like ICs or passive components that are on a reel, and it's a full reel, but I have no idea what it is. Parts number searches don't turn up anything. I have some vague information about them, and on those, if you can get me a link to a data sheet and be the first one to leave that in the comments, I'll reward you. I'll give you a tube of the ICs, or I'll give you a reel of the parts, depending on what the item is. That's coming up in the future. So again, this is the first one. Today we're going to be covering an item that, if I had received this like it is, and with what I'm going to show you here, I wouldn't have had a clue what it is, because there's just not enough here. And we'll do a teardown. I'll show you all of the pieces up close, and we'll figure out, at one point we've got 5 connections. At some point we'll power it up and we'll see just exactly what it does. And on this one, there's a mechanical element as well as the electronic element. And so let's dig in. Okay. Do a little zoom in here at the beginning. This has transformer, which is here. It's a stand cord transformer. It's got dual inputs for 120 volt AC or 240 volt AC, and then output that is, what have we got? Either 10 volts at 300 milliamps or 5 volts at 600 milliamps. Okay. There's also this relay on here on the same side of this board that you can see it right here. That guy, there we go. Okay, so standard type of relay. As you see there, it is a Songtron 812H-1C-C. Coil is B0, 9 volt, and then the contacts are kind of their standard contact ratings, 125 volt, 10 amp, blah blah blah, with all of the other voltage and amperage items on there as well. Let me zoom back here for a second. Okay, whoops. On this side also, there are the 2 8-pin ICs are 555 timers, so you've got some timing involved with it. And then this other IC is a quad NAND gate. It's a 4011. Okay, and then you've got capacitors. This green cap is it's a super cap, and its value, I saw it a second ago. It's not a huge one. It's a 5.5 volt, 0.047 farad, and that's really all the major components on that side board. There's some transistors. Everything is through hole, so it gives a little bit of an idea that this design has been around a while, because there's no surface mount on it, and nowadays you see surface mount on everything if it's a more recent design. Sometimes you will see through hole still though, like the transformer, the relay, those kinds of things still commonly through hole parts. So nothing Nothing too unique there. So let's take a look at the mechanical side of things. As I rotate this, you can see there's two printed circuit boards, and sandwiched inside of those two circuit boards is a metal piece. There's a couple metal pieces there. You can see some gaps and whatnot going on in there. And then as I rotate it around, you have a mechanism on this side that is a coil here that it's a solenoid setup where when this is energized, it looks like it's going to be moving this other linkage piece, making it move. And you've got a coil up here. It's a dual stacked setup, and that's really all the components that are on that side of the board. And one that I noticed here, and I don't know if you noticed it as well, but this little guy, it's not what it seems right here. That piece that looks like a little hat that's over the shaft that the spring's around. Well, that's a pop rivet. It wasn't made for this particular application as a special part. It's actually something that is used in sheet metal work. Now, if you're not familiar with pop rivets and sheet metal work, you may be saying, well, how does he know that? It turns out that I worked through high school and part of my college, beginning college, for my dad in his sheet metal shop. And we did all kinds of furnace systems, air conditioning systems, duct work, all sorts of sheet metal flashings and bending metal for different applications, and as well as rain gutters. And back lots of years ago, they used to use those pop rivets for fastening the pieces of metal together if you're making a box, or if you're putting together pipe that would go off to a room off of a piece of ductwork. You would use a pop rivet to fasten them together. When you were putting up rain gutter and you had a downspout that would come down your wall and get the water away from your home, pop rivets were commonly used to put all of those together. Now, I don't know how long ago, but at some point, pop rivets were replaced. They were replaced by screws. So you had a drill and went to cordless drills. You'd have a chuck on the end of it for a hex-headed screw that was self-tapping, and it made it so fast. You could go through, you could pop those screws in really fast, get a job done really quickly. They were reversible. You could have all kinds of flexibility with them. Well, pop rivets were great fasteners. They just were more time consuming. They actually, since they're a two-piece part, they probably were more expensive than one of these screws that they use today. Let's see if I can get my assortment pack open here without totally destroying the packaging, so that I can seal it back up, because I bought this. They actually are still available. You can still buy them. I got this at Home Depot. I'm sure that Lowe's and the other major hardware stores would still have them. You have all kinds of sizes here, and this one, if you look at that guy, it's identical to the one that is in here, right there. So there you go. It's a pop rivet. And you're going to say, oh, well, what does a pop rivet do? I can tell you why. Because with my experience working for my dad, I have all of the tools to demonstrate how it works. What it did, I got a piece of brass here. What I'm going to show you here is you get your basic tin snips and just a piece of brass I had laying around. You cut off a little strap of it here. And you get out. Now these tools, I've had these forever. They last forever. Very heavy duty, all hand tools. Very nice to work with. Whitney punch. If you haven't ever used one and you're doing a lot of fastening in sheet metal if you're doing maybe some boxes or straps or those kinds of things. These guys are the perfect tool to have. And it comes with an assortment of sizes. I happen to know that this particular pop rivet is an 1/8 inch. So this does not have the right punch pieces in it. So it's very fast to pop out the one that's here. But this guy, you can see there, this guy would be way too big. It's not an 1/8 of an inch, it's bigger. And I replace it with the 1/8 inch one that you can see is much smaller in diameter. That guy goes in there. Put the other in here. And it's ready to go. Okay, now we have an 1/8 inch punch ready to go. Just for this little demonstration, I'm going to bend this strap around so that it'll make a circle like so, and you punch it right at that point. And now you have a piece that you can pop rivet together. So you put the pop rivet in like so, and I have this pop riveter. I actually bought this a long time ago because I thought, well, I'm going to need it. I'm working on sheet metal stuff. I'm going to need a pop riveter. And I don't know, this is a Stanley. I don't know. Well, the pop rivets are DeWalt. I didn't look, since I already had this in Home Depot, I didn't look what they have. But they have to have a pop riveter if they're selling pop rivets. So I'm not sure what brand they have now. It might be this one. Anyway, if you're curious, there will be a link down below in the description. You could actually even purchase one through an affiliate link if you'd like to. But that's all described in the description. So anyway, here's the pop riveter, and it has 2 sizes. The assortment that you've got an 1/8 inch size, so all of them would fit into this smaller hole, the one up at the top. Okay, see that? And what you do is you make sure that it's all the way in, and that your metal is all flat, so that when you squeeze this, it's gonna get my hand in the right gripping spot here. It's gonna pull that shaft through the rivet, and it gets its name by popping when it's done. So there you have it, pop riveted joint together. Sometimes people will hammer on this to make it even flatter and move out bigger so that it won't pop back out of the hole by accident after things work around a little bit. But that's kind of a long-winded way of describing what they used here for this piece. And I look at that and I say, you know, they saved money by using a pop rivet that they could buy for a nickel or 10 cents a piece, rather than custom machining a part that would certainly do this job, but lots more expensive to do the design of it, lots more expensive to have the part manufactured over the years and years of life of this product. So I put that in the clever mechanical design category because they were resourceful and they utilized something that was available as a common fastener to solve a problem in a very inexpensive way. Some people might think that's cheesy or it's a kludge, but in the end I think it's clever. So anyway, that was your 2-minute tutorial on pop riveting. Okay, now let's move on. I want to now tear this thing down So now on to the teardown. Let's take these screws out. Take this plexiglass cover off. And I got the wrong screwdriver. We will zip this cover off. Now, oh, that's got a flat blade screw in it. That's interesting. Okay, it's out. It's out of the enclosure. Okay. So now, same thing as we saw before. Except this, now we want to figure out how we're going to wire it up. Where do these wires go to? Okay, and to get this apart, you take these standoffs off. Okay. One more. Okay, then this guy pops off of that one. There's a couple wires, 5 wires, that connect the two boards together. And on this side, looks like there's an opto-isolator here. This is a 4N26 and some resistors, and then there's a photo transistor on this side and a photo emitter on this side. A light emitting diode or infrared emitting diode on this side, or vice versa. But they're on opposing sides. Okay, that's another clue there that there's a pair here that's detecting something that goes through this slot. Okay, and as far as the wiring goes, you can see here that the gray and the blue come through and go to pins on the relay. Now I already ohmed this out, and there's no continuity between those two as it is right now unpowered. So my guess is they go between either side of a normally open contact, and that when this thing does its thing, detects its thing, that it closes that contact, and then the blue and the gray wire are connected together. That's my theory at this point. I don't know that yet, but that's my... So we don't have to worry about the blue and the gray because they aren't associated. We know for a fact they aren't going to be associated with power. They're for signal. They're for output. Now, the black wire is connected to one leg of this opto-isolator, and the white wire and the brown wire come in really close together, and they go the brown wire goes to this outer leg on the transformer, and the white wire goes to the leg next to it. Okay, and then the white wire goes to both of them. So what that tells me is the brown wire is one side, it's one leg of the transformer here, and the white wire is the other side. And the black, so you've got white and brown. The black wire just comes in and goes to this opto-isolator, which, from everything that I can see here, it doesn't have... It's hard to tell given that you can't see the other side of the board, and it is it's not a double-sided board. It's a single-sided board, so all of the traces and connections are right here where we can see them, which makes the troubleshooting a little bit easier without tearing off the transformer. But from what I see there, the black wire is powering one side of the opto-isolator. The white wire goes to another pin on the opto-isolator. So from that, I'm going to say the black wire has nothing to do with power. Okay, so to power up one of these units, it's white and brown. And if we do a check, if we ohm between, use the handy fluke here, if I check between the white and the brown, I get about 485 ohms. So that would be a typical resistance for the coil on a transformer. So I think that it's safe to say that I connect the brown and the white up to 120 volt AC, which supplies power to the transformer, to the primary. That then would power the overall circuit. Now, is there anything else? Actually, this looks like I can take apart the sandwich. Okay, if I now take, it's going to make all the mechanism, but it's so bent that I doubt anything is going to fall apart. And two more. We got one in this corner. That one. It does. And this one. That's okay. So now, screws and whatnot are so. Oh, there we go. Okay, there it is apart, and you can see that up here at the top the slot begins, it travels down and then exits off that side. There's nothing on this board, it's just a blank that is part of the sandwich to keep things together. And then you'll notice that there is the mounted coil. You can see that. The mounted coil is here at the top. So as you put something down, you put something in there, you see the mechanical little lever here. My guess is, if I can figure out how, and this thing may be too damaged for me to actually wiggle it. But my guess is that if this coil detects something, that this little tab then gets, I think the damaged part is not, it doesn't wiggle around. But it's definitely supposed to. You can see how bent everything is right in here. Right through there. It's not, this little solenoid, there's no moving parts right now because it's so bent, torqued. Okay, so here's the moment of truth. You have all the pieces, it's all apart, we've gone through part numbers, relay, transformer. What in the world is that? I'll give you a minute to think about it. Do 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 do. Okay, enough of that. I'll show you what it is. It turns out that I have my handy dandy terminal strip here, and I have my little 120 volt AC plug. So just for safety, I wanted to mount it to this terminal block, and then I'll put the terminals that we want to power up on the other side, and all will be well. this reminds me, when I had one of my first labs in college, doing all of the design, electrical engineering, and all of those things, we had a lab, one of our first ones, and it was basically an introduction. So we were being exposed to a lot of different things. One of our tasks was to use a flying lead 120 volt AC cord like this that we could plug in. We were supposed to connect it up to terminals on our little test fixture in order to do the lab assignment. And our professor at the time, he had a rule that if you were in the lab and you tripped the breaker twice, you were done, out of the class. So we were very careful. Well, one time I'm working with a pigtail lead 120 volt AC cord like this, and it's loose on this end. It hasn't been tied into anything yet, and I forgot that it was still plugged in. And I had disconnected it from its terminal strip, and now I've got these leads flying around that are hot with 120 volt AC. And it just so happened that at the time I used to wear this bracelet, and I had it on my wrist, and all of a sudden I hear the breaker pop, and I'm wondering, what the heck? How did my circuit go dead? And just fortunately, the professor had left the room and didn't know that mine tripped. And I went back in and flipped it again, flipped it back after I had attached it like it was supposed to. Still not knowing, I had no clue what caused it to trip. In fact, I didn't know that it was even me. I didn't know what it was, but I just knew that it had tripped. Well, I went home later on that day and I discovered it's worn off now, but you used to be able to see where a little bit of the copper was still on the bracelet, where it had hit it and made contact and tripped the breaker. Now you could say that that saved me, because it hit the metal of the bracelet, caused the breaker to trip, and it didn't do anything to me. But the point is, be very careful. Don't trip your breaker. Do not have live 120 volt AC leads. Make sure that everything's powered off, that it's unplugged when you're working on it. Safety first, okay? Always remember that. All right, now I'm going to reveal what the item is. Hopefully you've already, down in the comments, you've already put what your guess is, expressed your knowledge of what the device is. It just turns out that when I picked this up, it was in a box of a whole bunch of other electronic stuff. And I bought it at an auction years and years ago. And this one that was damaged is useless. If this is all that I had, I would have no clue what the thing was. But it turns out that there was a second one in the box. And the second one is just fine. Doesn't have any damage. Still has the pop rivet. All of the same mechanical linkages and whatever is all the same. So it's an identical unit, and the faceplate's dead giveaway. Now the other one, on this one, this little bracket piece was attached. You'll remember it was attached to the end of the board. Well, it's a die-cast piece that goes with this faceplate, and it is the mounting piece that mounts the faceplate to the rest of the system, the electronics and the sandwiched piece in between. Mechanically, it's what ties everything together. Now, the other thing that was missing was this other circuit board. It's a dead giveaway when I show you the front, but this circuit board has, what's this guy? He's a display driver, an ICM 7217. So all of a sudden, things are probably fitting together. We also have a couple of wheels to dial in 0 through 99, or 0 through 9 on each one of them. So this could the total here. Have you figured it out? What is it? I think most of you probably guessed when I showed you the inside track on this guy, this inside track here, and the fact that there's a coil that is here at the top end of it with a little linkage post here that'll energize. This is basically a metal slug detector. So if somebody's trying to put a slug in here that's ferrous metal, this coil detects the fact that it's ferrous metal, and it causes the solenoid to trip and blocks the entrance. It can't go in. But if it's a non-ferrous disc, it can slide right through there. So I'm sure you've all gotten it by now. It is a coin drop mechanism. So you put the coin in here, and if it's, like I say, if it's ferrous metal, then that little blocker solenoid pokes up and keeps the coin from going in. If it's non-ferrous, like a quarter, because this is a quarter unit, then it will let the money go in. And the little dial switches here set what this display is going to show us as far as what the required number of quarters are. And you if you don't recognize this, it's actually from a laundromat, a commercial washer or a commercial dryer, and you'll see them in a laundromat. Put in your coins, it washes your clothes or dries your clothes, away you go. So I need some quarters. Okay, I have some quarters here, and well, they're all quarters, and some pennies. And then I don't have ferrous coin slugs, but I have my handy dandy tin snips here. Spool it with a piece of, okay, that's pretty close. Okay, and then this one is a piece of sheet metal that is ferrous. Too big. So this might be something that somebody would make up that they think they're going to fool the machine with. Okay. Now, with the solenoid operating, I don't know that I can make it so that you can see. Maybe you can. Oh, there you go. You see the little tab right there. That will not let a slug go down if it detects a piece of ferrous metal, because that won't go out of the way. Now, the other detectors that we saw before, they're down further. This one that's not damaged, it also, you can see it right, if I get it, there's a coil on the other side as well. So there's not just two coils that are stacked there, there's three. There's a third one on the opposite side, if you can see it there. Okay, so we will connect this up. Like I said before, it's the brown and the white wire that we need to connect to the 120 volts. And these others. Now I'm going to have my handy dandy fluke here. I'm going to put it on beep. You'll be able to see it going there. So the idea is when those contacts close, we should get a beep. Okay, so we want to be clipped to the blue and the gray. Blue and gray. Now, I'll go back to my lab again. That same professor in that same lab, we worked on all kinds of stuff. We looked at all sorts of electronics. We did teardowns. We did repairs. You could bring in things for that particular class and try to fix. And one thing that he always told us and always reminded us was if you're dealing with high voltage, especially if it's 120 volt AC or 240 volt AC, or in the old vacuum tube type, the CRT type televisions, you dealt with some pretty high voltages. Thousands of volts and enough current that it could kill you. So he had the one hand rule. And that was another thing, that if you didn't observe the one hand rule, you were out of the class. And the one hand rule was, whenever you're working on something that's powered up, you can only use one hand. And hopefully it's obvious, the main reason for that is, that makes it so that you don't get that high voltage and whatever current it's at going across your body through both of your arms. You know, you don't have a current path that travels through your arms, both of your hands, through your arms and across your heart. So we all remembered the one hand rule. We were all safe. Didn't have any lab accidents with high voltage. And I still remember that to this day. His name was Mr. Dingus, and he is no longer alive. I think he passed away several years ago. He was a great teacher. Taught a lot of the electronic design classes and labs. It was a very good experience. So, I think we're all hooked up now. This guy, we're going to set, it's set to 2 and 1. I don't know what that means. Actually, I'll leave it set at what it is right now, and we'll just look at it to plug in this guy. Here's the big test. There you go. No smoke. It gives us a 12. So, coins to start, 12 coins. That's $3. Well, in some cases that's probably about right. But not for us, because we don't have, well, I guess I do if I run them through. Now, we'll take this first quarter and will it allow it to go in? Oh, see, I don't have any resistance with that peg that was across there. Now it's 11. Woo! Another one. Wow, that was glitchy. I don't know why it did that. It should have gone to 10. Oh, except I didn't let the other one fall out. So that's probably, if the coin had fallen out, like it's supposed to, then you put this one in, goes to 11. Put another one in, goes to 10. 2, 1, and now we should have the beep come on. Voila! You can't beat that. I love it when a plan comes together. Okay, now, that's really annoying. We'll reset it. And now we'll make it so that instead of 12 coins, I guess 12 is probably pretty common, $3 to wash or dry, we will make it 2 instead. So this time around, when I plug this back in, oh, how can that be? So the way it's set up is the washer or dryer, when it's done with its cycle, it comes back and the opto isolator is basically a handshake that says, hey, I'm done. And until it sees that, it's basically latched in to operate so that the person gets their full cycle time. Okay, my thinking here is that the opto isolator needs to be energized, like we were saying before, but one side of it, I looked on the old board, one side of it is tied to the white of the 120 volt AC. So and there's a 47k ohm resistor going from the white to the one side, to the LED, the emitter inside of the optocoupler. The other side then comes back out the black wire to this black wire. So it stands to reason then that the dryer or washer that the black wire is being connected to is the other side of the AC voltage. And when the black wire sees the AC voltage, then it resets the unit and says, hey, I'm done. So that's the theory. Let's try it. Oh. Ha! All you have to do is wait long enough and it resets. Okay, so I won't do that. What I did want to do was show how the slugs work. Now this one is the piece of aluminum that I chopped out. If I try to put it in there, so the aluminum will go in, but there's no real detection there. I think since this is so thin, it isn't the thickness of a quarter. I think it just snuck its way past that blocker. There we go. Okay, now it makes it very easy. Okay, the other one is this ferrous metal little slug that I made, but again, it's not as thick as a quarter, so I don't know how it's going to accept it, but it should detect. See, it's not allowing it. Whoops. That's my fault because the thing's so dang skinny. The mechanism, like with a quarter, when you push it in, by the time it gets in there, it's gone through. This guy, when you put it in there, it hits on there and it doesn't let it go through. So this won't let that slug go in. So the detection is working properly. Those coils have detected that it's a ferrous metal slug and it doesn't let it fall through properly. It likes to reset. And let's do the theory now. Since we're done, if I blow something up, we're already done. We've tested everything. But the theory is that this needs to be connected to the other side of AC power. There you go. So the way it is, you put in the money that it needs. So 1, 2, it goes off. The washing machine, the dryer, they do their cycles. When they're done with their cycles, it has to be some kind of a relay contact. They connect then the black wire to the other side of the 120 volt AC. Bam. It shuts off the cycle and it says it's ready to go again. Okay, there you have it. That is our first ever What in the World Is That? And hopefully you figured it out. It's a coin drop detector that's used on commercial washers, commercial dryers, those kinds of things. And it has the ability to reject ferrous metals, to detect them when you put them in the coin slot, and it won't let them fall down, but it gladly takes quarters. We didn't try pennies. The penny just sits on there and it doesn't allow it to fall through and be counted. Whereas if you put a quarter in there, it falls through, so it's back on. So I hope that was educational. I certainly learned a lot about it. I had no clue how a typical mechanism like this would work as far as detecting slugs. We deal with it all the time. Nowadays, not as much as we used to, because now you have lots of dollar bill acceptors, and now you can do credit card acceptance and payment, which we didn't back in the day when this guy was created, which this is 80s time frame. Didn't have even thinking about credit card readers and that kind of thing. In a laundromat today, I think they still use a lot of these. There's tons of them out there. So, hope you found that interesting. Maybe you learned a little bit, found out about detecting different coins and how a drop mechanism like this would work. Like I said at the very beginning, there's going to be a lot more of these what in the world is that features in the future. In the next few of these, I will be doing a giveaway. So you're going to want to check back. Hopefully you like that, and thanks a ton for watching. Again, please leave comments and questions down below the YouTube video. We love that, and we love subscribes, thumbs up, likes if you like the video, and thanks for watching, and we'll catch you next time.